Hello, we're going to look at why negative exponents do what they do. In my MBF3C playlist of those videos, I go through one way of understanding this in lesson 4. So if you want to check out that video, you can jump through the chapters to find that section that talks about negative exponents. But we're going to look at it in a slightly different way to hopefully understand what's going on with the pattern in order to understand what's truly going on with negative exponents, because it's a little bit of a mind trip. So we're going to look at an example and we're going to say, okay, y equals 2 to the x. So we're going to look at base 2 and we're going to see what's going on. We're going to look at the pattern to figure out what is going on when we end up having negative values of x. So we're going to do a table of values. So we have x and y, and we're going to start with x equaling 3. So if x equals 3, that means that y equals 2 to the exponent 3, which is equal to 2 times 2 times 2, which is equal to 8. Then if x equals 2, we have 2 to the exponent 2, which is equal to 2 times 2, which is equal to 4. Then we have x to the 1, which means that 2 to the exponent 1 is equal to 2, which is equal to 2. And then we have x to the 0, or x equals 0. So then 2 to the 0 equals 1. There's another video that talks about 0 exponents specifically. So if that doesn't make sense to you, go back and look at that. Okay, so we have, these are all of our positive values. We can see that that makes sense. That's what, if we put that into a calculator, that's what comes out. Hopefully that makes sense in terms of exponents. So what we're going to do is we're going to look and say, okay, well, we want to figure out what our constant ratio is. So each time when we go from one to the next, what is going on? So 8 divided by 4 is equal to 2. Okay, that makes sense, right? Because here we had 2 times 2 times 2. Here we only have 2 times 2. We had another factor of 2. Okay, so then to go from 4 to 2, if we do 4 divided by 2, it's also equal to 2. Again, makes sense. Okay, so then this one can be tricky. So going from 2 divided by 1 is also equal to 2. Right, because our constant ratio, we always want to do the same thing. So then to go to the next one, what we're seeing is that we need to divide it by 2. Because every time we can say, in order to go from one to the other, we see that we're dividing by 2. We're having a constant ratio of 2. So that means that if I wanted to find this number, if I didn't know this number, I could do 8 divided by 2 equals 4. And that gives me my next value. So 4 divided by 2 equals 2. Right? So that continues. We can always divide our previous value by 2, and that's going to give us what our next term is. So how that works for here is that, let's just continue. Let's do the next one. So we did 2 divided by 2, which is our ratio, equals 1. That gives us our x to the, when x equals 0. So then to continue the pattern, so once we have here, when we have x equals -1, so then 2 to the -1, that means we're really not sure what that looks like in terms of multiplying our bases. But if we follow this same pattern, if we say, okay, well, I take my previous value and I divide it by 2, which is my constant ratio, right? The amount that I'm dividing by each time. Well, that equals 1 over 2, or as decimal, 0.5. But we're going to leave it as a fraction because we'll be able to see the pattern. So we get 1 over 2. Okay, so then let's do it again. So now we have our previous value, 1 over 2 divided by 2, which is our constant ratio. Well, if we think about, I cook and bake a lot, so if we think about a half a cup divided by 2 gives me a quarter cup. If you do that on a calculator, which is going to be as a decimal, 0.25. But that. Now, okay, so this equals 1 over 4. Okay, and then let's do it again. So we have 1/4 divided by 2 equals, okay, well, if we have a quarter of a cup, dividing it by 2 is going to give me an eighth of a cup, which is 0.125. Again, the decimals, we don't see this pattern in the same way. There's definitely a pattern there, but we're really looking at the fractions to see what the pattern is. So, oh, I forgot to put it here. So 2 to the negative 2 equals 1 over 4. And when x is negative 3, 2 to the negative 3 equals 1 over 8. Okay, so great. We were able to calculate them. But then now, how do we connect it to the rule in terms of figuring out what's going on without having to do dividing always the previous one? That's a lot of work. So what I want you to look and see is that here, we know that 2 to the exponent of 3 is 8. So here, 1 over 8 is 1 over 2 to the exponent 3. And here, 1 over 4, well, we know that 4 is equal to 2 to the exponent 2. So 1 over 4 is going to be 1 over 2 to the exponent 2. And then we know that 2 is equal to 2 to the exponent 1. So 1 over 2 is 1 over 2 to the exponent 1. So we still have this our base 2 is still showing up. And we can still, when we have an exponent, we can still see that those are equal to each other. So what you hopefully are noticing is that when we have a negative exponent, our exponent, we can say we flip it, or we have the reciprocal. We have 1 over the exact same thing here, except that our exponent now is positive. That negative exponent goes away because it means that it's 1 over. It's a fraction. It's a smaller amount because we're dividing by 2 to get there. We keep dividing by 2, and so we're getting to a smaller amount. So we end up with 1 over 2 to the exponent 3 when our original power was 2 to the exponent negative 3. This is definitely a tricky one. So in general, how we write that is b to the negative x. So any negative exponent equals 1 over b to the positive x. And that's how it changes. So we don't just get rid of the negative. We have to do the 1 over because we're dividing by our base more times in order to get smaller and smaller amounts. I'm only going to do one example right now because that's a lot and it is a tricky thing to understand. Touch base with me if it doesn't make sense still, and we can continue to chat about how to make it make more sense. Okay, good luck.